Wow. So yeah, it's time to start talking about this 3x3s. I'll tell you what I would tell every class, and I do tell every class every time we start this. This is not difficult. It requires a lot of math problems in a row that have to all go well. So you're going to wind up doing a ton of multiplication, distribution, adding, dividing. I've never actually counted it. Sometime, someday, one of you should do that. I say usually I just make it up that like 30, 40 math problems all have to go correct in order to just solve one problem. Meaning that if at any point along the way you tee hee oops forgot a negative, then the whole thing is shot. It's a mess. Would someone shut that door? I don't, I, sounds like there's utter bedlam. Bedlam. Boy, put the blocker in there, homie, you rookie. Thanks. I should have said please. I'll make up for it by saying thank you. So as I said, you just gotta be on your game here. So we're gonna start with this. After the Thanksgiving break, when we come back, we will dive more into what three variable equations look like. There are some strange situations that can occur. They will not occur today. Um, I don't want to start the lesson and on the first day have you encountering systems with infinite solutions or stuff like that. So today we're just going to hammer out the mechanics of how to solve a big system. And we will only use elimination for this. Elimination is what will prep us for the row reduction that we'll have to do next. So no substitution. Obviously, we're not going to graph. That would be amazingly difficult. I couldn't do it. I'd have to use some technological assistance, I would think. Yeah. So anyhow, there you go. So the answer that we're looking for is going to have three parts. It's going to have an X, and it's going to have a Y, and it's going to be a Z. These have to go in order. The order in which your variables will be the order in which your triple will be written will be dictated by the order in which the variables appear. So generally, I'm going to keep you at X, Y, Z. Occasionally, the computer is going to sneak in an RST or a PQR, ABC, stuff like that. Did I already say ABC? But I'm going to try to keep you with X's and Y's and Z's. So we're not looking for a point on a piece of paper where two lines cross. We're now looking for a point in three-dimensional space. Those of you guys that play Minecraft would recognize how the XYZ coordinate space works, right? Do you guys play Minecraft at all? A little bit? So what happens is you have your X and Y axis that essentially face you, and then your Z axis is the one that comes towards you or away from you. So again, you guys that play Minecraft would know that your X and Z coordinates are the ones that determine whether you go forward, left, right, whatever. But then when you travel up and down, again, Minecraft diehards know this, that that's your Y level. And so we have three axes now. We have the X axis that runs sideways. I mean, it doesn't really matter. It's all relative. We have the Y axis that cuts it. So like it's a flat plane in front of you staring at you. And then the Z axis pierces through and comes towards you or away from you. So anyways, we're looking for a point in three-dimensional space where all three of these planes cross each other. And let's begin. I'll just throw this out. Anyone notice anything? What about them? You said fours. This is a three-dimensional fluffer puffer. So last week, I believe Thursday, was it Wednesday or Thursday? One of those. We talked about fluffer puffers, and a level one fluffer puffer with a 2x2 system is one where you don't have to do any prep work. One of the variables was already ready to self-eliminate. So all we had to do was add the two equations together and someone would go poof, gone, right? Well, this is a 3 by 3 fluffer puffer. We should be in love with this column right here. So at this point, and the other examples will not be like this. I just wanted to give you one of these. At this point, what we're going to do is we're going to combine some rows together to make the y's disappear. I'm going to say this a lot. This will be the first of about 40 times. Your goal is to kill the same variable twice. Need you to understand that. You can't target a variable, make it disappear, and then go back and target a different one. You'll wind up in a really nasty predicament. So what we're going to do here is we're going to take the top row, we call this, and the middle row, and we're going to add them together. You must notate on your paper what you're doing. And the way we do it is this. When you do row combinations in algebra, you want to tell someone what you're doing. Otherwise, people read it and go, I have no idea where you got that. So we write R1 plus R2, and then don't put an equal sign, just put like a little arrow. You don't want an equal sign because then you're going to have this big long equals thing from left to right, and nobody wants that. So let's talk about what happens when we add row 1 to row 2. Everybody got it? Row 1 is the top. I can label these for you in case you're already lost. The top is obviously row 1, the middle is row 2, and the bottom is row 3. You don't need to label those every time. I just figure like everybody knows that that's from this point on, everybody knows when we say R3 that we're talking about the bottom row. Notice I'm leaving R3 out of this for now. We'll come back to him in just a minute. So what happens when I add row 1 to row 2?
Yeah.
Give me the whole play-by-play. How many X's do we get? You should be looking right now at this yellow box because that's the X from row 1 added to the X from row 2. What do we get? We get negative 7 X's. Good. You should now be focused on this yellow box here, and I'm just going to keep moving this box around. What do we get there? Elimination, right? So we don't put anything. Don't put 0. That's always weird when people do that. Just, they're gone. That's what we want to, right? And I wouldn't cross them out there because you're going to need this stuff to be visible as you do more steps throughout the process. So just know that they eliminated, and now we're going to focus on the Z column. How many Z's do we get? We get 9 of those. And so right next to my resultant over here, my negative 7x, I'm going to put plus 9z. And then no row operation is complete until we also add the constants together. That's the yellow box over there. What's negative 12 plus 22? 10. So what we just did to you right now probably feels completely pointless. But what we did is create an equation with 2 variables. The goal here, once you see this big picture, it will be really, really clear, is we're going to take a 3 by 3, chop it down to a 2 by 2, and then down to a 1 by 1. And then we're going to work our way back up from the 1 by 1 to the 2 by 2 to the 3 by 3. And that's going to make a lot more sense in 5 minutes. Okay. So we're part way down to having a system like we worked on last week. But what we need to do now is make sure we kill the same variable again. Which 2 rows will enable that to happen? 1 and 3. That's the money answer. And if you're a little bit confused, take a look up here. Row 1 has a plus 4y, and row 3 has a minus 4y, just waiting for us. So if I add row 1 to row 3, I should get a second elimination of the same variable. That's the key. If you kill y once, kill him again. So the way I denote that for someone like my teacher or anyone else who needs to know what I did is I write down, hey, I'm going in. I'm about to do row 1 plus row 3. And it's harder for me this time to draw boxes because they're not connected to each other, but I'll just keep doing this. Here's row 1, here's row 3. See them? Add them together. What do you get? 7x. This is a next level fluffer puffer because if you're already thinking ahead, you can see that the 2 by 2 we're about to create is also a fluffer puffer. So I thought there couldn't be a much more friendly, user-friendly problem for us to start with than this. All right, we're still in the midst of row one plus row three. Row one, row three. What do we get? Elimination. Gone. So don't put anything. Okay, row one plus row three. What do we get? 7z. Perfect. Row one plus row three. Negative 42. Very good. Got it? Once the smoke sort of clears and you're able to see through what might a few minutes ago have looked confusing, you realize, wait, I just created an algebra 1 problem. I just created a 2 by 2 system that I now have to solve. I'm scaffolding my way down. I'm chipping it down. It used to be, I'm going to draw some boxes and then erase them. This thing in the green box is called a 3 by 3. This thing in the other green box is called a 2 by 2. So we're making progress. The goal here is to get it down to a 1 by 1. And a 1 by 1 will say something like x equals 4, z equals 3, something like that. That's called a 1 by 1, one variable, one equation. So now let's get out of our minds that we're learning something new today, and let's just focus on what we relearned last week. And let's focus on this 2 by 2. What do you see? Say again? Yeah, the negative 7x and the 7x make this a next round fluffer puffer. I can now draw my line of intent because I don't need to do any modifications. I can just go ahead and add them together. No more need to denote row operations. With 2 by 2s, clarification is not necessary. Everyone with any idea of how to do math would look at this and know what you're about to do. Okay, including myself. So you don't need to communicate to me when you do what we did last week. So when I add downwards, how many X's do I get? None. They're gone. Elimination. How many Z's do I get? And what's my constant? Perfect. And we now have a 1 by 1. So we had a 3 by 3. We made it a 2 by 2. We just made a 1 by 1. And now we have to solve it. And that'll give us the first of the 3 pieces of the puzzle. Divide both sides of that little baby 6th grade equation by 16. And what do you get for Z? -2. So as I would always do when solving any system, I'm going to now take this opportunity to build my answer. So I'm going to go over here somewhere and I'm going to write my final answer. I'll write it way down here in the corner. So the answer is blank, blank, -2. -2 has to go in the 3rd spot because it's my Z. And now is where you are smart and you work your way back up. It's a fact that if you want to solve for the second variable, you can only pick an equation that has 2 variables. If I went to one of the original equations that's in the upper left-hand corner, I wouldn't have enough information. If I changed one of these z's over here into -2, I'd be hosed because I'd still have 2 variables and I'd be like, I don't know what to do. So what we do now, this is where I say we're scaffolding back up. It goes from 3, 2, 1, 1, 2, 3. So we're going to take -2 and we're going to put it in place of z in one of the 2 red equations because those are the equations on the board that have 2 variables. As many as you know, you want to put it into an equation that has 1 more than that variable. No 1, put it in the 2. Which equation do you guys like better, the top one or the bottom one? Of these 2 over here.
Wow.
Bottom's fine with me. And they'll, as I've said before, they'll both work, provided that mistakes have not been made and don't get made, we'll get the same answer. Lena could put it in the top one, Lana could put it in the bottom one. They're both going to get the same answer for X. Clearly, we're solving for X, because if I change Z into a number, then that'll leave X as an unknown. So Dallin seems to like the bottom equation. So I'm going to take this bottom equation out right here, and I'm going to write it again. It's going to say 7 x plus 7z, right? Change z into -2 and then do the math as you go. 7 times -2 is negative or minus 14. Bless you. And now you've got yourself another little kitty equation, right? We can handle this purple one. What do we do? Add 14 to both sides, which gives us -28. And then divide both sides by 7, which gives us x equals -4. So I can now complete the second piece of the puzzle. I can plug -4 into his home, which is the x spot. And now it's time to storm the castle. This is where we cash it all in, and we're back all the way up to where we started. We started at 3, 2, 1. Then we went from 1, 2, and now we're back up to 3. We now have enough power in our arsenal to storm the castle and pick any one of these original 3 equations because we have enough information now to replace 2 of the letters with numbers to solve for the third. 3, 2, 1, 1, 2, 3. Back up we go. So we're at the end. Which of the 3 original equations do you guys like best? Top works for me. And again, it doesn't matter provided that mistakes have not been or will not be made. So the top equation, and I'm going to show a little bit of work on this one. I didn't do it last time, but I don't want to lose anybody. So the top equation will say 4 times x plus 4y plus 6 times z equals -12. Thought it would be prudent to show a little bit of good old-fashioned substitution here. So in place of where that blank is that used to say x, what am I going to put? -4, because now I know who he is. And in place of z, where that blank is, what will I put? And from here, I mean, you can see this is just basic skills over and over again. But there's zero tolerance for mistakes. None. And so when I work out the first term, what's 4 times -4? -16. And I'm going to leave the plus 4y alone. What's 6 times -2? -12. And your algebra teacher taught you that you should always combine like terms before you solve the equation. So on the left-hand side, we would identify that there's a -16 and a -12 that need to be put together. What do they make? -28. Could have shortcutted that one, but I don't want to set a bad precedent for your future endeavors. Next up, add it. What pronoun is it? Yes, so if we add 28 to both sides, -12 plus 28 is 16, and we complete the puzzle. Boom. So that means if you could picture those 3 flat surfaces given by the original system floating in space, 3 planes floating in space, they intersect at one point in space. Left 4, up 4, towards you 2. -4, 4, -2 is the point in space where the planes cross. Got it? Let's go again. This one will not be as much of a fluffer puffer. Okay, that one was fluffer puffer all the way through. The 3x3 was simple. The 2x2 was simple. We don't want that every time. That would be boring. So next up, 6x plus y. Well, I think on this problem, we're all going to be very 6x-ful. Thanks, Landon. I appreciate you, buddy. Funny, as a math teacher, the only way to really get any decent good at this job is just to do it a lot and learn what works and what doesn't work. And I used to teach 3x3 systems the wrong way. Um, and I got better years and years ago. I figured out, no, 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 there's a better way to do this. So if you were to watch an old video of me from 5 years ago, you would be like, oh my God, what a mess. There's a much cleaner way. That's just what I'm going to show you. I'm never going to go down that old dirty road again. So first off, you'll notice this is not a fluffer puffer, right? No column is singularly just ready to be eliminated out, right? So what you have to do, and again, it's just basic number sense, is look at the three columns and ask yourself which variable seems like it's the most agreeable to cancellation. Your instincts are very good if you said Y. X's would have been probably a secondary sort of, that's good. Z's, I would have probably referred you for some sort of mental evaluation. Um, so what we think about here is if I want to get rid of the Y's, and I'm fine with the Y's, by the way, we could do X's if you want. But what we want to think about is what number could I put in all of these places? Sorry, that's not supposed to be a zero. It's supposed to be like a circle. What number could I turn all of those numbers into to make them cancel? Yes, fours. And I want to be aware as I go. I don't want this to, you got to be smart about this. I don't just want them all to say four, four, and four. I need to have one of them that's an oddball, like either one that's a negative with two positives or one that's a positive with two negatives, so that everyone has an opposite to interact with, right? Having said that, the goal is where this red arrow is pointing, I want all numbers in that column to be fours, negative fours. So what do I need to multiply this top equation by? Correct. What do I need to multiply this bottom equation or the second equation? What do I need to multiply the bottom equation by? Nothing. Leave it alone. Okay. So sometimes you get these middle of the road ones. They're not quite fluffer puffers, but they're more of what like a level two would have been with 2x2s. Yeah, I've got some work to do, but it's not massive. So we don't need to show any more work right now other than what I've shown in red. And that is that, hey, this is what I'm doing to make my system become a fluffer puffer. So over here off to the side, get used to this. You're going to be rewriting things a lot. We're going to reconstruct the whole system off to the side. So what is the top equation now going to say? Mm. 24x plus 4y minus 20z equals one down. I could say two to go, but really the bottom one's just going to be a copycat, right? All right, let's hit the middle row. What's he going to now be? Equals negative 20. And then the third row, I'm just going to copycat. So that's a negative 6x minus 4y plus a z equals a 16. The goal is this. This is what we came for. And I didn't used to teach it this way, and I regret that. Every instance in which I taught it the wrong way, I feel bad about that. This is the single most clean, quick, sensible way to solve a triple system. Having said that, we just made a fluffer puffer. So, and by the way, it's pure happenstance that we happen to eliminate Y's. All right, I don't want you to think that's some kind of trend or thing. Like it's how the cards fell. Okay. So what is my first row operation going to be to create a cancellation? Say again. I like this. Row one plus row three. Last time we were able to do row one and row two. That won't work this time because those are both positive fours. And of course, they'll make eight. We don't want that. So we've officially begun the process now of creating our 2x2. What is now? It's so easy to get lost, by the way. because your brain and your eyeballs together are going to want to just lock to the wrong number. So somehow you've got to force yourself to look high, low, high, low, high, low. Middleman is out, right? So how many X's am I going to get? 18 is perfect. And again, if you said 32, you fell into the exact thing I was just talking about. I'm going to circle them for you. Row one, row three. And we're targeting rows one and three because that's where the Y's are plus and minus, right? So it was our very early on, and we already someone fell prey. So just be careful. What's my Y total going to be? Um, Say it again. Oh, my Y's. Yeah, Y's are gone, right? Everybody okay? I just had to ask. Z's are negative 19. I agree. Yes, and the Z's are here and here, row one and row three. So I have negative 19 of those Z's. And then my constants, what's negative 52 plus 16? It's definitely negative. If you owe me $52 and pay me $16, what do you owe me? Yeah, you whispered it at me, but I'll take it. Thank you. 36 is perfect. Negative 36. Okay, good. Okay. Which rows are we going to do next? What's our next row operation going to be? It's perfect. Yeah, let's do 200. Okay. Thank you. Okay. So by adding rows 2 and 3, you have to focus. Okay. Row 2 is down here. It's down here. So what do we get? 2x is very good. Nice job. What nice do we get? You guys do it to me all the time, so I can do it back. How many C's do we get? Nine's perfect. Good job. What's negative 20 plus 60? Awesome. Yeah, you guys whisper at me. I'm just going to whisper at you back. Take that. Yeah, this is great. So we have a lovely 2x2 system. As you can see, this, like its predecessor, is not a fluffer puffer, but it is now just an algebra 1 problem. It's a 2x2. So you have to reset now and completely start over. There is a correct answer to this question. I mean, there's a better answer to this question. Which variable will now be easier for us to eliminate? X, that's an excellent answer because X by eliminating the X's, I would only, knowing a little bit about basic math, I would only have to multiply one of the two equations. Path of least resistance, yes, please. And so we're thinking to ourselves, boy, wouldn't it be lovely if that number right there were a negative 18? The answer is, well, yeah. Can I make it happen? Yeah. Boy, oh boy, oh boy. So we're going to multiply this equation by negative 9. And so I'm going to reconstruct. I'm going to take this equation, the unchanged top equation. I'm going to go off to the side like this. And then I'm going to rebuild now equation number 2. What do we get? How many X's? Negative 18 X's. How many Y's or Z's, excuse me? Negative 81 of those Z's. And multiply the constants. Negative 9 times negative 4. So there we go. So there's our 2x2. We have it ready to go. It's ready to cancel. And now when we add downwards, here we go. We're going to add the first row. The X's, of course, eliminate. How many Y's do we get? I'm sorry, I didn't hear you. What is it? It's not 100. It's negative 100. Thanks, Lena. Yeah. And then what's negative 36 plus 36? Zero. This is where oftentimes students walk up to the desk and go, I think I did something wrong. I got a zero. And it's maddening for someone like myself. It's just a god darn number, right? Divide both sides by negative 100. You just figured out that z equals zero. Bam. People think zero is like, ooh, special. It's just a number. Got it? So, you just recycled the same joke. So since z equals zero, we're going to put zero in the third spot, and we now begin our journey back up. We're now going to go into the 2 by 2, right? And there are three equations on the board that you could use. There, I would venture to say, is this one, which I could call like equation one. You don't have to call them anything. I'm just trying to make a point. There's this one, which I believe I could call equation two. And the only other unique one on the board is this one. I could call him equation three. I feel like I know where I'm at on this. Which one do you guys like the best? Two seems to me like why I like that. So at the end of the day, though, they're all going to be pretty easy because I'm going to put zero in place of z. And so if you put zero like right there, what will equation number two say? 2x just equals negative 4 because the zero wiped out the z. Divide both sides by 2. What do you get? X is negative 2, and we can now plug a second piece of the puzzle in, leaving us with uno mas, and it's time to storm the castle. This is where you have accumulated enough strength in your mathematical army to go now and do what you set out to do. I come back with two knowns. So we go back to the original problem. And we ask when you, by the way, I would do the originals, right? I don't know why anyone would want to pick the big buffed up ones, but you could. Any of them will work. There are five unique equations on the board. The original three, and then the two we modified. I personally feel like we ought to stick with the OGs. Which one do you like? Second one is fine with me. So Morgan has selected that we're going to use this one. I like it. Pick any one you want. We come into this knowing what x is, right? X is negative 2. So the equation is going to say 4x plus 2y plus 4z equals negative 10. X, we figured out, is negative 2. Z, we figured out, is 0. Now it's time to math. Easy. What's 4 times negative 2? Notice I didn't even acknowledge the existence of the 4 times 0. I just brushed it aside, disrespected it. And then what do I do now? Add 8 to both sides, giving us negative 10 plus 8 is negative 2. Divide both sides by 2, and you can now complete your puzzle. So knowing now that y is negative 1, you're going to go all the way back into your solution and stick a negative 1 in there. Boop, boop. And if you really want to just be the most successful version of yourself, you could take all three of those numbers and plug them into every one of these three equations. It takes a little time. But if you want to know if you did, when kids go, can you tell me if I did this right? It's like, well, you could actually tell me. That just means you go to every x and change it into negative 2. Go to every y, change it into negative 1. Go to every z, change it into 0. And if the equation checks out, first one, second one, third one, then you nailed it, right? Uh, sure.
The negative 10.
Thank you. No problem. What do you think?
This processing next.
Ooh, well played, sir. I'm going to get our next example copied onto the board, and then I don't think we're going to make much progress on it, but I want to have a few words about it. So give me about 3 more minutes, 4 of your time. All right. So here we go. I am skipping example. Did someone just fart?
No, I didn't mean,
You okay?
yeah, guys, just kind of laughing.
About what?
The jokes that Lana made.
Just now? Oh, can I hear? Is it dirty?
No, not really.
Oh, did you? Oh,
Oh,
did I
yeah.
do it and I didn't even know it? I threw out one of those at dinner last night, and my wife just covered her face and shook her head. What? So let's see if we can make a little headway on this before we pack up and go our merry way. Yeah, listen, it goes, I have to ask this, but what do you notice? We
All
are.
have X's except
Jeez
the.
Louise, I've created a monster. The, the, I will say that once I got my teaching poop in a group, I finally figured out how I think to say this to students. This is good news. It's really easy initially to say, whoa, 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 I better ask about this. Something's wrong. Nothing could be more right. What happened here is because of the way the cards fell with this problem, is one of the 2 by 2 equations is already created for us. The only bad news is it takes away our freedom of choice. But take a look at this equation right here. Remember, our goal is to create a 2 by 2 system, right? So I could take that now, steal it, and I now am halfway done with step one. But I'm limited in the amount of choices that I have. And by limited, I mean I have one. Which variable do I have to kill now? I thought that was going to go better than that. Which variable was killed to create the second equation? Then which variable do I have to kill again? Correct. So in order for me to do that, I have to prep rows 1 and 3 because I need to get the X's to go boo boo, bye bye, dirt nap again. So we're going to take the top equation and we're going to multiply it by 3. And we're going to take the bottom equation and we're going to multiply it by 2. What number am I attempting to create? A 6 and a -6. And that's because I'm just fixated now on the X's. I say, if someone got out X once, I got to get them again. Even if they'd been a 9 and an 8, like it's not up to me. I'm going to see this through. So I'm going to take my top equation now and recopy it over here. It's -6x minus 3y plus 9z equals -24. I'm going to not even bother with this middle one because I don't need to do anything with that. I'm just going to worry about this bottom one. He is positive 6x minus 8y plus 8z equals -10. And again, I could take this one and copy it over here, but I'm worried that you might look at it and think that I have to do something with it. It's already done. That's great. I'm just going to kind of hold it there in the queue for now. So having said that, let's just finish what we came to do. Let's do row 1 plus row 3. What do we get? How many X's? None. They're gone. How many Y's? -11 Y's. How many Z's? 17. And the constant, -24 plus -10, -34. It's at this point now that I'm going to go grab my buddy from earlier. Remember this guy over here? 2y minus 5z equals 10. Let's bring him over. 2y plus 5z equals 10. And we have arrived at our destination. The goal here really is just, can I make a 2 by 2? And the answer, if I'm any good at this and you're kind of picking up what I'm putting down, you're seeing that anything's possible. Just pick one variable and murder it twice, and you're back down to algebra 1 level. So that concludes this. Obviously, I'm not going to give you the assignment today.
So we don't have to do any.
Goodness gracious. Uh, wow. I'll see you guys tomorrow. If you have highlighters, would you please bring them with you tomorrow? Make yourself a note. Highlighters.
So.